Yeah, good evening. In the last videos, sir, just we started actual concept of these data structures and algorithms. Sir, we have analyzed how you can able to calculate, how you can able to analyze performance of an algorithm. Suppose if I have any algorithm, how you can able to analyze that algorithm. So for any algorithm, if you want to analyze, we have two components are there for that. Okay, we have two components are there for that. What is the first one? The first one is nothing but space complexity. Space complexity means the amount of space required by an algorithm. Okay, so to execute or to perform that particular task. Sir, how you can able to calculate this space? For example, in your algorithm, how many variables you are using? Okay, how many memory locations you are utilizing? So based on that, the space is going to be considered. But make sure some people got so much of confusion in the last session. Instructions, looping statements, those things won't occupy any space. Space means it is a separate entity. You have to talk only with respect to the variables. If you take any variable, it will occupy one unit of space. If you take an array, how many elements are there in that array? Based on that, space will be allocated. Okay. So for collection, we have to use a size attribute for getting the size. Based on that, we can consider it under array concept only. Okay, like this we have. And there is a basic formula. The total space is nothing but a fixed part. Somewhere if any constants are there, constants also will be allocated in some memory, right? So for that, and also variable part. Okay, and we have calculated space complexity for some algorithms, like how you can calculate for addition of three numbers. So if I want to calculate the area of circle, how you can able to do that? Okay, then even we have calculated space complexity for sum of n natural numbers and sum of elements present in an array and sum of elements present in an array by using recursion. So majority of the students got confused in the recursion. That's why, sir, I came up with three more examples in today's session. Okay, what is the first example is, sir, I want to calculate space complexity for factorial of the given number. Okay, so I want to write an algorithm to find factorial of the given number using recursion, sir. That is very, very important. Using a recursion, I'm going to prepare the algorithm and we have to calculate the amount of space required for that algorithm. Sir, algorithm, let me consider the factorial, right? Let it be fact, which is going to occupy a variable called n. Okay, so already we have solved this problem. Do you remembered or not? If n is equal to 0, then we have to return 1. Otherwise, we have to return, sir, what is the formula? Factorial, right? N into, sir, we have to call again fact of n minus 1. So this is a simple algorithm. Just for our convenient purpose, I have written. This is nothing but a simple algorithm to calculate, okay, recursion. To calculate factorial for the recursion. Sir, for this we have to calculate time space complexity, sir. Okay, sir, space complexity. Okay, space complexity is nothing but, sir, how to calculate for this algorithm? Sir, what is the first step, sir? First, we have to identify how many statements are there. Listen carefully. We have a variable called n is there. Okay, so that n we are leaving here itself. Okay, we are leaving here itself. That means where it will be stored in the stack. That's why it is going to occupy one space. Okay, maybe consider I am going to call for factorial of n n. Then how much space it is going to occupy? 1 unit for storing the n value plus 1 unit to make the recursive call. Okay, to make this recursive call, one more unit is required. Sir, now recursive call second time it is executed. Sir, how much space is required? Same concept, right? N, one space is required. So plus again for this recursive call, one more space is required. Some people may have a doubt, sir, when n is equal to 5 or when you got n value, already you allocated some space for n, and inside the stack, maybe you are maintaining that function call for n minus 1. Again, when you are executing n minus 1, why you required n minus 1 space and n minus 2 a separate function call? Because so in this case, we are not staying in this algorithm. We are going to execute one more time. Okay, so this complexity of a space is for one time iteration. This is for next time. Next time in the sense it is not a looping statement. It is again evaluating that algorithm. That's why this concept will come into the picture. Similarly, if you take n minus 2 also, same one amount of time to store n minus 2 plus one amount of time, one unit of space to call the next one, and so on. Suppose if you take f of n minus, maybe let us consider n minus, so n minus 1. Sir, in this case, how many units? 1 plus 1 unit. But if you take f of n minus n, how many units it is going to take, sir? Here, the value of n will become, the value of this n will become 0. When n is equal to 0, we are going to return 1. This 1 is also a constant, sir. Okay, this 1 is also a constant. Previously, we have not stored this. Suppose in your algorithm, if result is equal to 1 is there, then if you are taking result here, this will occupy 1 unit of space, but this won't occupy. But here, this r is equal to 1 we have not taken. Separately, we have given the value constant. So it is also going to occupy one space. But again, is it calling? No. That's why, sir, here the value of f of n will become 1 unit of space. Now you have to calculate the total amount. So if you calculate how many n's will be there, sir. So I think n times it is going to execute. Okay, n times it is going to execute. Every time this one, maybe 1 plus 1, 2, sir, 1 plus 1, 2, sir, 1 plus 1, 2, 1 plus 1, 2. I can say 2n, 2 into n. Suppose if n is equal to 5, sir, 10 times it may use, 10 amount of space it may require. Sir, at last one amount is there, right? So 2 plus 1. Sir, the total space complexity of this factorial algorithm is nothing but 2n plus 1 units. Okay, sir, you can consider this as a big O of n, something like that. That part we will discuss later. As of now, we are not considering those things. Okay, so as of now, here how much space it requires? 2n plus 1 units of space is required. So can you please confirm? Do you have any doubt in this algorithm? Yes.
Yes, sir. Sir, actually, when the n is zero, we are comparing it with zero, right? So
Hmm.
that zero is a constant also. So why we are not counting that space?
N is equal to 0. Yeah, you can consider, sir. If you take that 2n plus 2, you are going to get. But
Okay,
anyway,
I
some
mean,
small, yeah, you can consider whatever you have said is correct. But small things I am ignoring because these constants, see, in the first algorithm is also, if you take, we have calculated somewhere addition of three numbers. This is negligible. This is also
okay.
negligible. This is also negligible. Whenever you are getting
Mhm.
n values, only we have to consider those things. I think
Okay.
if you people have an idea, you can get it. Big O of n, big O of n square, log n, like this we will take. So we won't
Mhm.
consider that constant parts. If you see internally, you can take. Otherwise, you can ignore. Just only outline point of view I have considered. Okay.
Got it. Got it. Thank you.
Yeah, I request everyone to please confirm. Is the calculation of space complexity for this factorial, is it clear for you people? Everyone, please confirm. Yes, I request everyone to please respond, friends. How f of n is equal to 1 plus 1? Just now I told, see, Abhay, here n is there. For this n, some amount of space is required. So again, factorial of n minus 1. For your example sake, I am taking. So consider a small example. So don't think a big logic. Sir, for example, consider you want to purchase three items in a supermarket. Abhay, listen carefully. You want to purchase 3 items from a supermarket. Sir, you have one bag is there, or some items are there, or you have laptop. So whenever you are going to supermarket, you need to surrender your items into the in that particular security guard. Sir, you have submitted your laptop and you have taken the token. That means what? They have allocated some room for your laptop. Then you went and you purchased something. Sir, you came out with bill, all these things you came out. Sir, you forgot to purchase one more item. Again, you are trying to entering into this particular supermarket. Again, you need to provide these particular values. You have to surrender these values at the security guard or not? Yes, definitely. Again, they have to allocate some room for you. In the same way here, whenever you are calling with n is equal to 5, so it is going to allocate some space. That is 1 unit. For this recursive call, they will maintain a stack. For that, one amount of space is required. So totally, two amount of space is required. 2 units of space is required at very first time. Clear? Vishal, just concentrate only on this particular. You can neglect these things. Clear, Vishal? Please neglect these numbers. So it depends on the numbers. For example, if I'm taking one more variable, you will get one. Or if I'm taking there, I used array concept. Okay. So that's why
Sure.
maybe I used plus one extra like that.
No worries, sir. Got it.
Yeah. Yes. Yes. Yeah. Now, sir, I will write one more algorithm. You have to give solution for this. Yeah, Ashish, always it will be ignored in the recurrence relation. I will explain that part also, don't worry. So as of now, I have not given the full-fledged space complexity notation, sir. Just how you can able to calculate that part alone I am discussing. Once if you go to these asymptotic notations, so there you can able to calculate, okay? Yeah. Sir, now I want to find out space complexity. Space complexity for prime number or not application for using recursion. Same recursion methodology again I am taking. Sir, how you can able to calculate for this? First, let me generate the algorithm. Sir, already we have implemented this algorithm. Do you remember is prime function is there? Okay, so we are going to check whether if I value is equal to 1. If I is equal to 1, then we are going to return true. In addition to n, we are going to pass I also. Sir, now after this, what will happen? Else if n percentage I is equal to 0, then we are going to return false. So otherwise, what we have to do? We have to return, sir, is prime of n comma minus minus I, something like this we have taken. This is nothing but what algorithm we have taken in the previous cases, how it is going to work. Now I need to analyze this algorithm. Sir, how you can able to calculate space complexity of this is prime function? Sir, let us check how it is going to be calculated. So first time it is a recursion, right? So this one is going to execute one time. Space complexity of is prime is equal to, sir, first time, maybe if you are passing some n value, okay, so is prime of, suppose if you are passing n value, then it is going to execute. So forget about these base conditions, we will verify later. So it is going to check whether it is prime or not. If it is prime, sir, what it is going to do? It is going to make a recursive call. It is going to make a recursive call. So by passing n comma I minus minus, how much amount of space is required here? 2 units, because one is used to store n, another one is used to store this I. Okay, another one is used to store this I. Okay, but in previous example, we have considered only 1 unit for this. What is the reason for that? Because we have only one argument is there, but here we have two arguments are there. That's why 2 units. Suppose if you have any other variable here, maybe n plus I, then additionally plus 2 you have to take. But here we don't have that scenario, just a function call with the 2 parameters. So to maintain this, we are going to take this one. Now, what is the next one? It is for n. If you take for n minus 1 also, it will take same. If you take n minus 2 also same, n minus 3 also same. At last, if you take n minus 1, sorry, n minus n, there are two possibilities are there for termination. One is nothing but when the value of I is equal to 1, there may be a termination, then return true. We are not calling the function again. We are going to return. So to maintain this, we required one amount of space. Similarly, or there may be a chance. Sometimes it may take this one also, false also. So actually we should not count, but let it be. Okay. So we are going to take either 1 or 1. Okay. It is going to terminate by using this condition, or it is going to terminate by using this condition. So if this condition is satisfied, then program will terminate with the success. If the condition, this one is satisfied, the program will terminate with the false condition. That is, it is not a prime number. So in these two, any one will execute. Okay, any one will execute. That's why I'm going to take either one or one unit, any one. Okay, so the the total space complexity for this algorithm, can you please post it on chat window as per your knowledge? What will be the space complexity for this algorithm? Yes, please. Everyone, I request everyone to please post. Already I have given the complete idea. Yes, just we have to post, that's all. Yes, majority of the students are giving correct answers. See, I am taking only 2n. Okay, I am considering only 2n is a prime of this one is going to take 2n is the fixed. After that you can take anything. After that you can take anything, no problem at all. So concentrate on this linear. Okay, if it is a constant, you can ignore. If it is a power 0, you can ignore. If it is power 1, you have to consider that n. If it is n square, if it is n cube, it is a square root of n, log n, those things we have to consider. Plus a constant, you can ignore always. Okay, so because it depends on the variables, all these things, right? Okay, so I think everyone is giving correct answer for this. This is the way how you can able to calculate factorial for this. Okay, hope it is very clear for you people. Please confirm, do you have any doubt on this algorithm? Yes, I am requesting everyone to please respond. Do you have any doubts up to this? Why one, not one for return? See, for return it won't to take any space. The value whatever is there, for that it will take space. So at a time, if you are calling is prime, both will not be stored, any one will be there. That's why I have taken either one or one. If you want, you can take both plus 2, you can add, no problem at all. Clear? Yes, sir. Now that's all about the space complexities. You can take a small algorithm and you can calculate a space for that. So the next one, what we have, time complexity.
Question.
Hmm.
One question, sir. The one we did just now, which was for prime, in that example, we are not counting the past arguments as one unit, like n and I is prime.
Is prime function. See,
Yeah.
whenever you are passing headings and all, I'm not considering, sir. I'm
Okay.
concentrating
Okay.
only on this point of view. Okay.
Okay.
So
Got it.
here we are calculating, right? That's why.
Mhm.
These are the parameter passing things, sir. These won't be counted. Okay.
Sure. Sure.
Yeah. Because these values we are using in the algorithm, right? There you can count that one. In the previous example, you can see, for example, if you have addition of 3 numbers, we are not counting here, we are counting here. If you count here, you can ignore this. Okay, So next, time complexity, sir, which is very, very important. Space complexity, we won't give that much importance, but time complexity is very, very important. Okay, because as a programmers, we know less number of variables if we use, definitely space will be reduced. That concept everyone know. Okay, just a minute. Yeah, so that point everyone know. That's why they will concentrate only on time complexity, how you can able to reduce time. Sir, what is mean by time complexity? Sir, the time complexity.
Sir, one question.
Yes.
In the previous question,
Hmm.
for return function also we will be consuming 1 unit of memory, right?
Not for return, sir. Whatever value it is returning for that.
No, for is prime function, if it is getting called in the recursion, for that we will consume 1 unit of memory, right?
Yeah, sir. For you are getting confusion, Pradeep. See, if you call is prime by passing two arguments, okay, it will execute. You are talking about return true or return false. Which one?
No, I'm talking about is prime, last one.
Yeah, this one
Else.
only it is going to execute. Here I have written, right? First time, suppose if you are giving 7 as a input, it will execute one time, right? In that, it has to maintain the statistics of n and I variable for that two amount. Okay.
What about we are calling is prime once again, no?
Once
In
again,
that
you are
case,
going to call. In that n value will be overridden, or it will take a separate space, but separate space only will be considered because function call to function call, the data is going to be changed, right? Here it is n, that's why you are giving confidently. But sometimes if it is n minus 1, then definitely change will be there, right? Memory location.
yeah, in case of recursion,
Hmm.
we are considering memory allocation for method call also, right?
Yes, every method call. Yeah, method call in
Yeah.
the
So
sense,
one,
see, for your understanding purpose, I told like that. But actually, method call includes everything, whatever there in that. Luckily, in previous program, we have only one argument is there. That's why just I have explained in this format. But whenever you are getting two arguments, for this recursive call, it requires 2 units of amount. Are you getting the
I
point?
was thinking 1 unit for n, one
No,
unit
no,
for
no.
I, and 1 unit for
1 unit
return
for no, 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 no,
method.
no,
Okay.
no, no, not like that. So return won't occupy any space, sir. Just for your understanding, I am trying to explain in a small steps. Okay. In the previous program also, that's what you are getting confusion. So here for n, I told 1 unit. For this, I told 1 unit, right? So I used the term called to store this recursive call. To store this recursive call means what? Internally, n minus 1 value is going to be stored, right? That point of view I am explaining. Clear?
Okay, sir. Got it. Yeah. Thank you.
Yeah.
Excellent, sir.
Yes.
Hello. Sir, how you are taking 2n, sir? Actually, if you will take n is equal to 7,
Hmm.
then 7 will not, I mean, the value
Sir.
n minus.
If you take 7, don't concentrate only on 7. See, in addition to this, we are passing one more argument. For these two arguments, 2 units of space. Very simple. So I think you have attended already is prime function by using recursion program implementation I covered. Have you attended that session?
Yes, sir, I did, sir.
You can please cross check. There I explained very clearly how that function is going to be invoked. Somewhere I covered is prime function. You can cross check this one. Okay. So here I explained very clearly how that algorithm is going to work. Please cross check that once. Okay. Then you will get clarity. Here we have two arguments are there. That's why 2 units of space. Simple logic. Okay. Right. So the time complexity of an algorithm, is the amount of time, okay, amount of computer time it needs, okay, it needs to complete the task. Sir, how much amount of time is required to finish this task? For example, so if you have given, okay, sir, you need to take the Python course for the students. How much duration you are going to take? Sir, my time to complete this Python course is nothing but Sir, 45 to 50 days. That means almost 2 months you can expect. But if the same course is handled by Durga sir is going to take additional 2 months or 3 months extra. But there is a slight difference is there. So my concentration is so for normal level people, for average students and for above average students, they can understand my words. So small things I may not cover because so I feel that everyone knows about that. But what is a SAR concept? So everyone, the person who don't know anything, they have to understand from the scratch. Like that, SAR is going to elaborate everything, but the content is the same, the concept is the same. So the way of projection is different, right? So in the same way, for every algorithm, so I can write one code, other person can write another code, other person can implement the program in by using some other logic. So finally these three algorithms are going to execute and they are giving a required output for the given inputs. But which algorithm is the best? So based on this time complexity, we can able to decide. Sir, I have only 2 months duration is there. Better to join Prakash sir batch. Sir, I have no time limit, but I need to understand the concept. Better to join other faculties class. Like this, sir, we have the decision based on time. Here also, for every algorithm, for every program, time complexity is very, very important. I think you can imagine whatever I'm telling. Okay. So time complexity of any program, time complexity of any program or algorithm is equal to, sir, we have both the times, compile time plus execution time. How much time it is required for compilation, how much time it is required for execution. But I will ignore compile time, just I will go with only execution time. We can ignore compile time because, sir, compilation will be done only one time, only one time, right? So that's why I'm not going to concentrate on that activity because, sir, when the algorithm is executing on the processor, already compiled algorithms only will execute. If you have any syntactical mistake, compiler never generates any other format, intermediate code or bytecode, right? That's why. Okay, we are going to ignore this compile time. We will concentrate only on runtime, sir. This is nothing but what we have. Okay, sir. Here, yes, sir. We have different methodologies are there for calculating time complexity. In that, one of the method is nothing but step count method. Okay, step count method to calculate the time complexity. Step count method. Sir, how this step count method is going to work? First, we have some basic formulas are there. Just I will provide that basic formula. Then I will go with examples. Sir, slowly I will add these formulas one by one. Okay, sir, for algorithm, okay, for algorithm heading, sir, it will take zero amount of time, 0 units of time. So for braces, if anywhere, if you are encountered the braces, it will occupy zero amount of time. Okay, sir, for expressions, it requires one amount of time. Listen carefully. For expressions, one amount of time. In that expression, if you have 10 variables also, sir, how much spaces are required? 10 units. Sir, how much time is required? Only 1 unit. Remember that. Okay. And sir, for if conditions, okay, otherwise, yes, for if conditions, okay, for if conditions, how much amount of time is required? 1 unit based on that condition. Okay, sir, for looping statements, for loops, how much time is required? Sir, it is based on based on number of iterations, based on number of iterations. Sir, in general terminology, I will use the word called n because in our looping statements we will use only n, right? For example, if I want a factorial for find a factorial for the given number, n times it will execute. Okay, so that n is nothing but for loops. So as of now, just remember these 5 points. Sir, during upcoming classes, I may add so 2 or 3 extra points also. So for algorithm heading and for braces, it is negligible. Even the space complexity also we ignored. But for expressions, for if conditions, for looping statements, for expressions and if conditions, it requires 1 unit of time, but for looping statement, it requires n. But don't worry, I will take 1 or 2 examples so that you can understand well. Please confirm, is the theory part of this time complexity concept? Is it clear for everyone? Yes, I request every student to please respond. Clear up to this, friends? Komal, here 1 unit in the sense second or nanoseconds. It is not considerable, just you can ignore. Okay. So because it depends on the clock speed, processor speed, all these things. Okay. You can measure in any point. That depends on the calculator.
Sir, could you please explain the formula? Means like compile time plus execution time. So
Sir, yes.
yeah, again we are saying that execution time. So like why?
Compilation time and execution time, in the sense, for example, consider I have a meeting in 3 different locations. At 11 o'clock, I have a meeting. At 1 o'clock, I have a meeting. At 3 o'clock, I have a meeting. So at early morning, so at 9 o'clock, just I got fresh up and I got make up everything, and just professionally I have get ready, and then I started to first meeting. After that, again, I want to come back to home and I will fresh up and I will refresh one more time. Again, I will go for next meeting. Like that, I want to do. It is only one time refreshment. Once if I am ready, sir, that entire day I am going to plan accordingly. The same way, once if you prepare the program, so one time compilation process. Compilation process in the sense what compiler is going to do? It will identify any syntactical mistakes are there or not, or in the language level, is there any replacements that we have to do or not? Everything it will take care. Once if everything is crushed, it will give one product, bytecode or object code, anything it is going to give. So we are calculating, once if you got that code, how much time it is taking for execution. That part only we have to consider, because the product, once if you received, once if you installed in your machine, then you have to consider the time, how much time it is taking. But you
Yeah,
can't
but
consider.
we in project we have the different algorithms are there, right? Algorithms in the sense we have the different classes are there. So in that case, how we are considering the time
See,
complexity? Because
you are not getting my point. At that, say, consider simple application is there. For the application development, it may require 1 year or 2 years or 3 years. So that is in compilation process only. We should not count that time, or we should not count that space. Once if the product is ready, once if you install that product, how much time it is taking? We have to consider only that one, right? Are you getting my point? Clear?
yes, sir. Yeah.
See, there are two things are there: compilation, execution. But time complexity means, see, if I am constructing a house, I will tell proudly, sir, my house construction almost it takes 6 years. Okay, then just now I went to that house. But in future, if anyone is asking how many days you are there in that house, what I am going to tell, sir, I am in this house for about the past 2 years. I want to include the construction period. Are you getting the difference? So compilation time is different, execution time is different, but in our point of view, both are important. But once if the product is ready, other people will see only execution time. They want to see how much time you have taken for preparing the product. Clear?
Yes, sir.
Yes. You can see best example movies. The execution time is only 3 hours. That's all. Strict restriction will be there. But compilation time means what? How much time you have taken for taking that movie, some years together. But execution time is only limited. Yeah, I hope you got the answer. What is the expression and the condition difference? Ashok, you will get it soon. Please wait for a few more minutes. Variable assignment taken any time? No, Abhay, that will be considered as a expression. I will explain with the help of examples. Don't worry. Okay. Any other queries?
Yes, hello, sir. Sir,
Hmm.
my question is, in the interview, what will they ask? Like in the form of unit or in the form of second or nanosecond, like this?
See, just you can even they are not going to expect in the time. Even they are not going to expect in the space. They will ask these notations, that's all. For example, they will give, array merge sort algorithm is there. How much time complexity merge sort algorithm is going to take? Sir, strictly speaking, all the things, whatever I'm explaining is from scratch. No one is going to ask these things in the interview. Even for the programming purpose for you, don't expect all these things. Just remember what is time complexity, how you can able to calculate time complexity. But for algorithms, already some time complexities are there. We have to follow only those because the steps are fixed, right? We have almost 15 sorting techniques are there. In that 15 sorting technique, every sorting technique is having its own time complexity. So based on that time complexity, which one will execute fast, we have to include that sorting algorithm in your application. Like that we have to think. So they will ask time complexities for specific algorithms like searching, binary search, linear search, sorting techniques, or any other greedy method approach. How much time complexity it will be there, like that they may ask. For that input stuff I am giving. Clear?
Okay, sir, clear.
Sir, if the same program runs in a different system with different hardware specification, uh, time complexity will change it, sir.
Definitely, sir. It depends on the language which you are implementing. Suppose if your language is a platform dependent, definitely there will be a change. Even you need to rewrite the code also. Suppose if a programming language is a language independent, then no issues. It won't be depends. See, if you take Java or Python, so irrespective of operating systems, the time complexity is the same. Okay.
Sir, if this, sir, what I'm asking is if the same program run in medium level processor or high end processor, time
No,
will
no,
be.
no, no. There will be a same time complexity. Time won't be changed, sir. Processor is not directly proportional to algorithm. Processor is proportional to number of algorithm that you are executing. Suppose if your processor capacity is 1 GB, maybe 10 or 15 tasks you can able to execute. But if you push 100 tasks, the processor is not in a position to respond. Then automatically all the tasks are going to be down. So that is with respect to hardware configuration. We are not responsible for that. We can't prepare an algorithm which should work in one MB's processor or 1 GB processor. Like that we can't prepare. We will prepare algorithm based on our requirements. So hardware requirement is a separate category. We should not correlate with each other. But your question is correct question, Manoj. Clear?
Clear, sir.
Right.
Hello, sir.
Hmm.
Sir, my question is the times complexity is varying from one language to another language?
No, no,
Like,
sir. No, sir. No, no.
like in Java and Python, like Python
No,
code
no,
is
sir.
less than the Java code.
Yes, that will be good, sir. But with respect to the number of instructions or with respect to the algorithms, how it is processing, internally a number of differences will be there. But such type of things won't give any differences, sir. That's why Python and Java both are in strong, both are having same scopes. But why people are feeling Python is very easy? Because of library support. That's all. In the back end, they have written the code for your program. For example, if I want to implement a program to perform sorting algorithm, sir, I have prepared some 10 sorting algorithms. I will search for the best and I will use. Already best algorithm is implemented in Python internally. Just you have to call that sort. Once if you call sort, automatically it won't sort. In the background, that library is going to be executed. There, whatever algorithm they have followed, that will becomes under picture. Clear?
Okay, sir. You mean, sir, already defined your library not be involved in this time complexity?
Definitely it will be involved. Definitely it will be involved. So that's what I'm telling. See, if you write Java code for sorting, how many lines of code you are going to write? Just assume I am going to write 10 lines of code. If you write Python code for that, for sorting purpose, I will use only one line. What is that one line? L dot sort. But internally, that L dot sort mechanism is already there. So in that what code they have written, we need to calculate the time complexity for that also, right? Because whenever you are calling L dot sort, directly it is not executing. So internally, some library is there. It will go to that library. It will execute all the instructions and it will come. So we should not count this as a time. you have to count this one is also time, because when you are executing at 9 o'clock this execution, so you got output in 9:03. That means 0.03 seconds where the program is executing. It is executing internal instructions. It is also a time, right? Clear?
Okay, sir. Okay, clear.
Yeah. So because of this particular small instructions, the people are feeling Python is very easy. Yes, of course. But internally, n number of things are running in the background. Right. So hope all your doubts got clarified. Execution time and runtime is the same. Yes. Both are same. Sir, I will take one simple algorithm. As usual, addition of 3 numbers. A simple program I am taking. Sir, what is the algorithm for this? I can write like this. Algorithm. Okay, algorithm. Something like addition, which is taking A comma B comma C. Three inputs it is taking. Sir, now directly I am going to return. Okay, directly I am going to return. Oh, sorry. Yeah. So directly I am going to return A plus B plus C. Sir, what is the time complexity? What is the time complexity? I will consider this as a first line. Okay. So this as a second line. So this as a third line. So this as a fourth line. Like this I am taking. Sir, time complexity for first line is nothing but 0. Time complexity for second line, okay, is nothing but 0. Time complexity for third line is nothing but how many units? 1 unit. Very good. Sir, time complexity for fourth line is nothing but 0. The total time complexity of this addition algorithm is nothing but 1 unit. Sir, here constant. Yes, of course, constant. You can ignore these constants, sir. So nothing will be there with that. Okay. Because every program execution is having some time limit. Okay. Sir, they are going to keep food for us. So you can stay in the restaurant minimum 1 hour. So if you order only one idli, you can able to eat that one idli within 1 or 2 minutes. Then you can stay remaining time also. But if you order almost some 20 or 30 items and with your friends, if you are there, 1 hour time may not be sufficient. Other time may required. You need to pay for that. Okay. So if any constants values, if you are getting, just you can able to ignore. Just now this rule I said in the space complexity also. Whenever you are getting a space in terms of constant values, you can ignore because those are negligible. Okay. So the time complexity for this algorithm is nothing but 1 unit of time only to execute this instruction. Sir, don't feel that it is having 3 variables. That's why 3 units. No, you can take n number of variables, but this instruction, this expression will take 1 unit, because in the rule I have told expression is going to take how much unit of time? 1 unit of time. Okay, sir, hope this algorithm is very clear for you. Can you please confirm? Do you have any doubts on this first algorithm?
So can you please explain it again?
Sir, which one, sir? Where you got a problem doubt?
1 unit.
Yes, sir. This is an expression, right? In Java or Python, in any language, it is an expression. So there is a rule. Expression will take how much amount of time? Only 1 unit of time to execute. That's why this one is going to take 1 unit. Heading will take 0 units. Braces will take 0 units. Only in this algorithm, I use the expression. That's why it is going to take 1 unit. Forget about this return. We should not count. Just we have to take only expression. Clear?
Clear, sir.
And some people may have a doubt. Heading means method name. Yes, Srinivas, correct. Some people may have a doubt. Sir, algorithm. So addition of A comma B comma C. I think you will get some clarity here. D is equal to A plus B plus C. So return D. Return D. Okay. Sir, same algorithm we can able to take like this also. Okay. Return A plus B plus C. Sir, if you ask anyone, sir, in this, sir, case 1 is best algorithm or case 2 is best algorithm, means definitely the people are going to select case 2. What is the reason? Sir, here they are not looking with respect to time. they are looking with respect to space complexity. Because what is unnecessary use of this D? Because sir, when you can go for these type of scenarios, if you are using D multiple times in your algorithm, then you can store this addition. Maybe in future we can use. Okay, so for example, consider I want to calculate sum and average. Then for sum you can take a plus b plus c. For average you can take sum by 3. Okay, but this you can't take a plus b plus c. Again, a plus b plus c, sir, by 3. You can't take like this because multiple times if you evaluate, again unnecessary time is required. Okay, are you getting my point? So like this, we can able to reduce the instructions based on our compatibility. Okay, sir, I hope everyone got clarity. So the basic time complexity calculation for simple algorithm. Clear? Constant is also an expression, Yogesh. Constant is also an expression. Okay. Yes, time complexity for these both are 1 unit.
Method also considered as an expression?
No, sir. No, sir. But once if it is came into the recursion, then scenario will be different. That part I will explain later.
Okay.
Yes, sir. Now I can say almost just we covered. Okay, just we covered 10%, 10% of DSA with Java. Okay, sir, can you please confirm at least when you are attending the first session and now you are in almost 6 or 7 sessions completed, right? So now just for my interest, I am asking this question. At least you got some idea or at least you have learned something from this. Can you please confirm? Yes, very good. Majority of the students are giving. Yes, very good, very good. Yes, very good, very good. Yes, correct, Srinivas. Yeah, notations will be covered compulsory. Yeah, right. Yeah, we are going very slow. Yes, I will accept that. I already told in the beginning itself. Sir, this is the first time I am taking data structures batch in Durgasoft. Of course, in my engineering colleges, I have taken this subject for academics and also I have taken this subject for placements. Okay. So, but in Durgasoft, first time I am taking this. Okay, of course I have the content, but I need to convert that into a meaningful examples so that you should not confuse. So if it is a blackboard and if it is a chalk piece, then according to university format we will go, but here that is not the case. Okay, so that's why it may take some time, but first batch, that's what I am giving in advance. Okay, so I will take definitely time, but I will give the best product for it. Okay, yeah, thank you, Asif.
Yes, sir. Sir, in between time complexity and space complexity, we have to prefer more to time complexity, right?
Less time complexity. If an algorithm
Yeah, I
is taking
understand.
less amount of time, that algorithm
Yes,
is
sir.
the best algorithm. Okay,
We should not go for space complexity, right?
generally we will ignore space complexity, sir, because you know, right? So only for large amount of data, generally space won't be considered, because when you are preparing itself, we will write algorithm in that manner. Okay, by habituated we are going to write less instructions only, right? People will feel like that only, right? So space complexity you can concentrate, but not as much time complexity. You need to concentrate on time complexity more. Okay,
Okay, sir.
yeah. because you know the data is becoming very large nowadays.
So one more thing, sir. Like
please.
I missed some sessions, so how we can access the recordings?
Sir, please contact admin team, sir. Our admin team will provide you assistance for that. Okay.
Actually, I asked them, then they told that to ask the faculty only. So
You are
that's
talking about recordings or running notes?
recording session, sir.
Recording session admin people, sir. Because running notes only I have. Just give the clarity for the admin team. So better to take. Okay, I will inform them. Your name is Sumit, right?
Yeah, Sumita.
Sumita. Yeah, I will inform them, but you just bring a message to them.
Sure, I will do that.
Yeah.
Hello, sir.
Yes, sir.
Today also my first day. So is it possible to get a previous classes notes and recording?
Yeah, running notes I will share, sir, but recordings admin people will provide you access. Please wait 1 or 2 days. Admin team. When you have registered for this course?
Yes, sir.
When you have registered for this course? Today?
No, on the 4th October.
I think you got the access. Please cross check once.
But where is the recording, sir? I don't have.
So it will be there in Google Drive. I request everyone to please open your Google Drive. There you will get the shared folders. Okay. Yeah, Nitesh, running notes also I am going to share. The persons who registered 3 days back, up to that I have given the access. So the people who registered 3 days back, that means day before yesterday and today, I will give access tomorrow. Okay.
Okay.
Java, core Java class, once if it is started, my new batches, I will inform in the regular class. Okay. Don't worry. Yeah, please. Someone is speaking. Sir, as of now, the topics are tentative, sir. Already in the beginning itself, I have given running notes. It is there. Okay. The subtopics, no, sir. No, sir. We are going on flow. As of now, it is not prepared. As of now, it is not prepared. I will go with the flow. Yeah.
Excuse us, sir. Will you create any WhatsApp groups so that if we have doubt, we can discuss about there also?
Yeah, I'm looking for the huge strength, sir. Almost 200 members registered for this course. For 200 members, of course, majority of the students are watching the recordings. But I'm thinking for that. Okay, we will see the possibility and we will create a WhatsApp. Soon we will do that.
Okay, sir.
Yeah, I will be active in WhatsApp, but not Telegram. That's what the problem. Okay, we will see. Right, friends. So I'm going to upload this running notes within few minutes. Okay. We will meet for the continuation tomorrow as usual at 7 o'clock. Tomorrow we will see the time complexity for few more algorithms. Maybe if possible tomorrow itself I am going to introduce that notations. We have some notations are there to measure these time complexities. Okay. So that part we are going to consider. Okay. Yeah. So I will upload these running notes within a few minutes. You can check it and download. Okay. Yeah. Thank you, sir. Yeah. Good night. Thank you. No, it will be decided UK. That will be decided and I will share.